Okay, everyone, welcome back. We are on 1.2 Reflections and Stretches, Part 2. Hopefully, the investigation that we did on stretches specifically begin to help you understand what we do for a vertical stretch about the x-axis and a horizontal stretch about the y-axis. There's different things going on there. So let's define what a stretch is. A transformation in which the distance of each x-coordinate or y-coordinate from the line of reflection is multiplied by some scale factor. Okay, scale factors between 0 and 1 result in the point moving closer to the line of reflection. Scale factors greater than 1 result in the point moving further away from the line of reflection. A stretch changes the shape of the graph, unlike translations and reflections, but does not change the orientation. Okay, it changes the shape, but it doesn't change whether it points up or down or if it flips around, okay? When the output of a function y equals f of x is multiplied by a non-zero constant a, the result, y equals a f of x, or if you divide both sides by a, you can rewrite it this way. This is a vertical stretch of the graph about the x-axis by a factor of the absolute value of a. Okay, remember factor of the stretch, whether it's a vertical or horizontal stretch, it's always the absolute value of that parameter. Okay, we never say by a factor of -2. Okay, if a is less than 0, then the graph is also reflected in the x-axis. So if a is -2, then the vertical stretch of the graph is about the x-axis by a factor of 2. But since a is less than 0, a equals -2, so the graph is also reflected in the x-axis. When the input of the function y equals f of x, on the other one, the horizontal, is multiplied by a non-zero constant b, the result y equals f of bx is a horizontal stretch of the graph about the y-axis by a factor of, this is what we saw in our investigation, 1 over the absolute value of b. So you pull out the b value, remember the b value is different than the factor of the stretch. Okay, factor of the stretch is what you multiply by to change the graph to. If b is less than 0, the graph is also reflected in the y-axis. Okay, let's do a couple of examples. Example 1, single stretch. Okay, we're just looking at one stretch. Given the graph of y equals f of x, so we have this, whatever this function is, right? It is what it is, right? State the mapping notation and sketch the graph of g of x. Okay, state the mapping notation and sketch the graph of g of x. So I'm going to label my points like this. So I have, so 1, x, y, and I'm mapping it to x 1/3 y. Okay. Okay, I'm going to plot these points, or at least write them down, and I'll show you how they change. -4, 3. So I'm just reading the points off of A, B, C, D, and E. Okay. If I'm applying we'll go over part 2, describe the transformation, state the mapping notation, and sketch the graph of g of x. This is a vertical stretch. Okay, and this is about the x-axis. Okay, so the mapping notation, only the y value changes on a vertical stretch. So I have -4, 1. And this is A, this is, sorry, A prime, B prime. B prime becomes -3, -1/3. So we're multiplying all the y values by 1/3. C becomes 0, -1/3. So that's C prime. D becomes D prime, which is 2, negative 1. And last, e prime 6, 0 becomes, well, doesn't change, 6, 0. Let's plot those. So I'm going to plot these all in red. Negative 4, 1. So let's take a look at this. Investigate. 1/3. So I'm multiplying all the y values by 1/3. Well, if I take a look at this, that's at 3. If I multiply 3 by 1/3, visually you'll see we take 1/3 of 3, that's 1, so we end up there. Okay, so visually you can see that the y value shrinks to 1/3 of the original y value. Okay, let's graph the rest here. Negative 4, 1, negative 3, negative 1/3, right there. 0, negative 1/3. Oh, sorry. Okay, I see a mistake here. Just a second, folks. Letter C is 0, positive 1. Okay, so sorry about that. I want to fix that. Okay. So this becomes 0, positive 1/3. Okay, so I have fixed that. Sorry about that. Okay, so 0, positive 1/3 is right here. Okay, next point. 0, 1/3, got that. 2, negative 1. Okay, and then 6, 0. Okay, this is what our transform function looks like. Let's describe it. 2. Describe the transformation. This is a vertical stretch about the x-axis by a factor of a, which is equal to the absolute value of a, which is equal to the absolute value of 1/3. Here's 1/3, and that just equals 1/3. Describing it further, so x coordinates remain the same, but y coordinates are multiplied by a factor of 1/3, that's my a value. Y values move closer to the line of reflection, and that's what we described above with all those definitions, right? So you see all the y values actually moving closer to y equals 0, and they move closer to the line of reflection, y equals 0, by a factor of 1/3. 3. 3 says star all invariant points. Invariant points means points that do not change. Okay, and that's at 6, 0. So right here, invariant. 4. State the domain and range of the new functions. Okay, domain. Do it in red. Domain x such that x is greater than or equal to -4, but less than or equal to 6. X is an element of all real numbers. Range. Okay, and I want you to do this in, we did it in set notation. We need to be conversant by doing this in interval notation. So square brackets, -4 to 6. This is also your domain. And then the range. Y such that y is greater than or equal to -1, but less than or equal to 1. Y is an element of all real numbers. Or in interval notation, square brackets, -1, comma, +1, close the square brackets. Next page, let's keep going with these examples. Next one. What's going on when g of x equals f of 2x? So different kind of transformation. This is our b value. Okay. So 1, this is example 2. State the mapping notation and sketch the graph. Oh, did I do mapping notation? Oh, let me go back. Go back to example 1. I did not do mapping notation, folks. Did I? Oh, I did right here. Mapping. Sorry. Mapping notation. Right here. Okay. Next example. State the mapping notation and sketch the graph. So I'll do this by going 1, x, y. Okay, what are all the points for x, y? A, -4, 3. Oops, sorry. -4, 5. Okay. B is -3, -1. C is 0, 2. D is 2, -6. E is 3, 0. Okay, and it's transformed to 1/2 x, y. So this is the mapping. A prime is at -2, 5. Okay, B prime, well, I'm multiplying the -3, the x value, by 1/2, so that's -3 halves, -1, okay, and so on. So C prime is 0, 2. D prime, multiply that 2 by 1/2, that becomes 1, -6, and E prime, that is 3 halves, 0. Okay, how in the world are we getting 1/2 as our factor when the b value is 2? So remember, b value, different from the factor. Okay, let's remember this, folks. B value is 2, right here. Okay, factor, this is different when we do horizontal stretches. Okay, factor is 1 over the absolute value of b. So that's 1 over the absolute value of 2, and that equals 1/2. So the factor is what you multiply for a horizontal stretch. The factor is what you multiply all the x values by to transform the function. Okay, and that's what we've done on the right side here. Okay, 2. Describe the transformation. So this is a horizontal stretch about the y-axis by a factor of, I'm going to pause here, by factor of 2 or by factor of 1/2. Remember, b value and factor is different when we're talking about horizontal stretches. Okay, pause here, think about it, 1/2, right? Right here. So by factor of 1/2, y coordinates remain the same, but x coordinates, what happens? X coordinates multiplied by a factor, you guessed it, of 1 multiplied by a factor of 1/2 x values move closer to the line of reflection. So we're using the line of, we're not reflecting here, but we're using the line of reflection as our reference point. The line of reflection, we said it's in the y-axis, so the line of reflection is the equation x equals 0. So x values move closer to the line of reflection by a factor of 1/2. Okay, let's take a look at this. So I'm going to graph this right here. A prime is transformed from -4, 5 to -2, 5. So -4, 5 to -2, 5. So it moves closer to the line of reflection by, here's our line of reflection. Okay, by a factor of 2. So before, point A was 1, 2, 3, 4. Now it's just 1, 2. So it's moved by a factor of 1/2 closer to the line of reflection, which is x equals 0. Okay. Let me plot these. So -2, 5, -3/2, -1. So -3/2, -1. Oops. Okay, right there. 0, 2. 1, -6. And e prime 3/2, 0. 3/2, 0. So let's connect the dots. Okay, does that look like a horizontal stretch about the y-axis by a factor of 1/2? Sure does. Okay. Let's see, what is next here? I'm running out of room here. So I'm going to state that 3 star the invariant point. It's at 0, 2. Okay, last one, 4. It says domain and range. Okay, I'm going to just show this in set notation, but I expect you to know how to do it in interval notation. So x such that, here's our boundaries. X is greater than or equal to -2, but less than or equal to 3/2. X is an element of all reals. Okay, and then range, y such that y is greater than or equal to -6, but less than or equal to 5. Y is an element of all real numbers. Okay. Whew. Okay, next one. Let's keep going. More and more practice. Practice, practice, practice. Okay. Example 2, single stretch and reflection. Given, so before we just did just a single stretch, right? Just one factor. Now we're going to mix it up and do 2 transformations in one. We're going to do a stretch and a reflection. Okay, one of each. Given the graph of y equals f of x, state the mapping notation and sketch the graph of g of x. Okay. Okay, I see a -3 here. So this is going to transform into x 3y and then into x -3y. Okay. First, the vertical stretch by a factor of 3. Okay. So remember, absolute value of a equals absolute value of -3. So My a value is 3. Okay, and that's my factor. And then a is less than 0, so I multiply by -3. So that's my mapping. So let me step through each of these points and show you what happens. So let me list them all. Okay, let's do one at a time. So we'll do the vertical stretch first. That's -4, 9. I'm multiplying all the y values by 3. -3, -3, 0, 3, 2, -9, 6, 0. Okay, and then remember, we're also doing a reflection. Well, which way? Reflected in the x-axis. Okay, so it's a vertical reflection reflected in the x-axis. So the y values are all going to be multiplied by -1. So -4, -9, -3, +3, 0, -3, 2, 9, and 6, 0. So I'll label these A prime, B prime, C prime, D prime, E prime, and then I will plot these in red. Okay, so what do we got? A prime is -4, -9, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. B prime is -3, 3. 1, 2, 3, 1, 2, 3. So this is B prime, A prime. Okay. C prime is 0, -3. D prime is 2, 9. Right there. And E prime is 6, 0. Okay. Let's describe the transformation. This is a vertical stretch about the x-axis by a factor of 3. Also reflected in the x-axis. 3. State the invariant point, or star the invariant point. So the invariant point doesn't change right here, folks. Okay, so that's at 6, 0. And lastly, domain and range. So domain, I'm going to do it with square brackets, -4, 6, close the square brackets. That's interval notation. Range, I'm going to do square brackets, -9, comma, +9, and there's my domain and range. Okay, letter B. Let's do the same. I'm going to do mapping notation. So 1, x, y, 2x, y, and -2x, y. Well, how do I get that? What does b equal here, folks? b equals -1/2. Okay? The factor is 1 over the absolute value of b, so that's 1 over -1/2. Well, that is equal to 2. So I have my horizontal stretch factor of 2. b is less than 0, so 2 becomes -2. So I multiply all my x values by -2. Okay, let me write out all these coordinates. Okay, multiply x coordinates by 2, so that's negative 8, 5. Okay, and so on. So let's write these out. Okay, and then apply the reflection in the y-axis. Okay, so I'm multiplying all the x values by negative 1, so that's 8, 5, 6, negative 1, 0, 2, negative 4, negative 6, and negative 6, 0. Okay, so this is A prime, B prime, C prime, D prime, E prime. And remember, these are the coordinates of the new transform function. So I'm going to plot these. 8, 5. Okay, it's A prime. B prime is 6, negative 1. Okay. C prime is 0, 2. D prime is negative 4, negative 6. And negative 6, 0. 1, 2, 3, 4, 5, negative 6, 0. Okay, so that's C prime, D prime, E prime. Okay. All right. 2. Describe the transformation. This is a horizontal, so all of this, horizontal stretch by, horizontal stretch about y-axis by a factor of 2. Also, a reflection in the y-axis. Negative 2, right here. Invariant point, label it, put a star by it, right here. And that invariant point, it doesn't change regardless of original function or transform function at 0, 2. Okay, 4, domain. Let's do set notation this time, x such that x is greater than or equal to negative 6, less than or equal to 8. X is an element of all real numbers. Range, y such that y is greater than or equal to negative 6, less than or equal to 5. Y is an element of all real numbers. Okay.